Alright, we're still on Euclid Book 3, proposition number 35, and I felt a little more explanation was needed. Alright, when we talked about the lines AE and EC, well, here's line AE here, okay, and here's line EC here. Now, if we were to take the length of AE and transfer it over here, and then take the length of AEC, see EC right here, and transfer it over here, and then we made another AC, well, be AE up here. Let's say this length right here. This one is equal to this, and this one is equal to this. Okay, so we have the length of AE and the length of EC. We made another length of AE and another length of EC, and as you can see, this forms a rectangle. Okay, so the rectangle contained by these two lines is what we were talking about in the last part of our proof. Now, what about the square? Okay, we told you EG was the square of EG. Well, EG is here. This is the length of EG right here. Okay? Now, here's the length of EG. This is exactly the same length. This side's the same length as this side. This side's the same length as this side. And this side is the same length as this side. So all four sides here are the length of EG. Therefore, when we told you in the proof that if you were to add the area inside of here plus the area inside of here, you would get the area of here. Okay, you say, well, where did this square come from? Well, this square came from the length of line G to line C. Point C, okay? Point G to point C forms a line, and that length right there forms one of the four sides of this square. So this length is equal to this length, and this length is equal to this length, and this length is equal to this length. Okay, so one more time, the area inside of here plus the area inside of here equals the area inside of here. Alright, and then we went on with the proof. And we said that the area inside of here plus the area inside of here plus the area inside of here equals the area inside of here plus the area inside of here. Okay? So if we added these two areas together, we would get the same area as if we had added this, this, and this. Alright. Now, the area inside of EF. Now, where is EF? Well, here is line EF. And we're talking about the square of EF. Well, EF here is the length of one of the four sides of the square. So we have the length of EF. And this line here is exactly the same size as this line right here. So this is the square of EF. Okay? Now, the area inside of EF is the same as the area inside of EG. Well, here's the area of EG and the area of GF. So if we added these two areas together, we get the area of this. Alright? And we go on and on. The square of FC, well, where's FC? Alright, here's F, and here's C. Okay, if we were to form a square with this length right here, we would have the same amount of area in that square as the area of GC plus GF. Well, where's GC? Well, here's GC. We can form a square using the length here, and the square of GF, which is right here. Okay? So, let's see. GC plus GF, these two areas right here would equal the area of the square of FC. And I know I don't have FC drawn out here, but that's okay. You can figure that out for yourself. You've already seen how I do all this, so you can do that for yourself. Alright. Therefore, the rectangle of AE and EC plus the square of FE equals the square of FC. Now, we already know that the length of FC and the length of FB are exactly the same. How do we know this? Well, first of all, here's FC and here's FB. They come from the center point F to the outermost edge, which in this case is B, in this case is C. It's C. And as we know, all radii of a circle are equal. So therefore, the rectangle formed by the lines AE and EC plus the square on EF equals the area of the square of FB. Okay? Now, the square of EF is here. Okay? And the square of FB is here. Now, the area of the rectangle DE plus EB. Well, where is DE? Okay? DE, okay, and EB. Well, here's EB. So if you form the rectangle with these two lengths right here, and you added the area of square FE, well, here's FE here. We can form a square out of that. It would equal the area of FB. Well, where's FB? Well, here's F and here's B there. Alright, so now we know that the area of the rectangle formed by AE and EC plus the area of the square formed by FE is equal to the area of the lines DE and EB, which this is DE and EB right down here, plus the area of FE, which of course is this one right here. Okay? Now then, this finally brings us to our final conclusion, that the rectangle formed by the lines AE and EC equals the area of the rectangle formed by DE and EB, which is what Euclid wanted you to prove in the first place. Alright, I hope you got all this. If you have any questions or comments, leave them in the comments section below. I will tell you more in a future video, so stay tuned.